Eric is back at it again. Today we'll be solving special case systems of equations.
So in the last three videos, you learned how to solve systems of equations by graphing, elimination, and substitution. This video is going to be showing you all these weird things that can happen. So let's look at this first example. Solve each linear system by graphing. So y equals 1/2 x minus 4 and y equals 1/2 x plus 2. So let me graph that. My old friend Desmos. Nope, my bad. Alright, start graphing. So the first one said y equals 1/2 x, what was it? Minus 4. And the next one was y equals 1/2 x plus 2. Alright, so now we're supposed to find out where do these lines intersect. Just to get a good view of this, let me try to zoom in a little bit, or zoom out. Looks like they're not crossing at all. They're never gonna touch. Why is that? These lines are parallel. If you remember, they have the same slope. That means that they're never going to cross, and there is no solution. So what we write for this, if they never cross, down here I write no solution. And we could know that even before graphing just by seeing that they have the same slope and that they're parallel. Alright, let's do this one. We want to graph these. You can use Desmos. Before you do, I want you to solve each one for y. Okay, go. Alright, let me solve the top one for y. We've got 5x plus 3y equals 6. I'll do minus 5x. Minus 5x cancels. 3y equals minus 5x plus 6. Divide by 3. Divide by 3. Divide by 3. Y equals negative 5/3 x plus 2. Now let me do that bottom one. Alright. 3y equals negative 5x minus 3. I can divide by 3. Divide by 3. Divide by 3. Cancels. Y equals negative 5/3 x minus 1. Alright, so I got this equation right there. That equation right there. Let me graph those in Desmos. So the first one was y equals negative 5/3. Y equals negative 5/3 x plus 2. And the next one was y equals negative 5/3 x minus 1. I'm looking at that. Let me zoom in a little bit, see if those are actually touching up. So these lines, they look like they're never going to touch. They have the same slope, so they are parallel, just like the last one. So number 2 is also no solution. And I can know this without even graphing because they have the same exact slope and they are parallel. Alright, now I want to talk about the 3 different outcomes when we graph a system of equations. The first one, this is what we've been doing in the first video in this chapter. You have one solution. The lines, they have different slopes and they intersect at one point. This is just one solution. The ones we just did, they have no solution, right? The lines are parallel. They have the same slope, so the slope is the same, but the y-intercepts are different. Different y-intercepts. So there's one up here, one down there. So different y-intercepts but same slope, and you will have no solution because they will never ever cross each other. The third one, it says infinitely many solutions. The lines coincide. Alright, so the lines have the same slope and the same y-intercept. So if you're doing one of these, and I say, okay, the first line is y equals 2x plus 1. And the second line is y equals 2x plus 1. You might be thinking, hey, those are the same line, right? They are the same. So it's like one line directly on top of the other line. And where do they intersect? Well, they intersect everywhere, right? Every single spot on these two lines is a solution. So we say infinitely many solutions. There's not one, there's not two, there's an infinite amount. And again, these have the same slope and the same y-intercept. They're basically the same exact line. Alright, so now I want you to try these examples on your own. Solve each linear system by graphing. I want you to tell me, does it have one solution? Does it have 0 solutions? Or does it have an infinite amount of solutions? Alright, so try it on your own, pause it, and go. Alright, so this first one, the first equation was already solved for y equals 3x minus 6. So I took the second one, y minus 3x equals 1, and I solved for y. I did plus 3x on each side. These 3x's canceled. So I have y equals 3x plus 1. So then I graphed y equals 3x minus 6 and y equals 3x plus 1. There's my graph. I'm looking at it, they look pretty parallel to me, and they're never going to touch. They have the same slope, so that means we have dun 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 dun, no solution. Alright, let's do the second one. So we have the first one, y equals 4x minus 1. It's already solved for y, that's good. The second one, let me solve this for y. So I divide by negative 2, divide that by negative 2, and divide that by negative 2. That cancels, so I have y equals negative 8 divided by negative 2 is 4x. 2 divided by negative 2 is minus 1. So the bottom one is 4x minus 1, and the top is 4x minus 1. It's the same thing. Right, same exact thing. You don't even have to graph it if you don't want to, but let's do it for fun. So if I go to Desmos, we have 4x minus 1, that's the green line. Y equals 4x minus 1, blue line. There's two lines right there, the same exact line. So what we would write for the amount of solutions is infinitely math teacher, not a good speller, infinitely many solutions. There we go. So the first one was no solution, second one was infinitely many solutions, and just as a reminder, the third option is one solution. That's when you have an answer like 4, 3, just one solution. Alrighty. You might be thinking right now, Mr. Durkis, but what does this look like when solving with substitution and elimination? Well, I'm going to show you right now. So let's try to solve this system by substitution. If you look at this bottom equation, it's already solved for y, so that means I can substitute it in for this y right there. So I'm going to rewrite the first one, negative 16x plus 2. Instead of y, I can write 8x minus 1. 8x minus 1, and that equals negative 2. Alright, now I need to simplify this. I'm going to use the distributive property. Before I do that, let me just write negative 16x. And now 2 times 8x, that's going to be plus 16x. 2 times negative 1, and that's going to be negative 2. And that equals negative 2. Now I want to combine my like terms. So over here I have negative 16x plus 16x. Well, those are the same thing but with different signs, so those cancel. So what I'm left with is negative 2 equals negative 2. Whoa, that looks kind of weird. That's weird. Alright. Instead of telling you what it is, I'm going to just leave it there and do this second one first. And then we're going to compare what we have. So let me do this one with a different color. How about green? Alright, it says solve by elimination. So, what can I cancel out over here? Nothing right now. But if I multiply it by 6, right, this will become negative 6y, and those will cancel. Alright, so let me write that down. So, 6 times 3x, that's 18x. 6 times negative y is negative 6y. 6 times negative 2, that equals negative 12. Now I'm going to write the top one. Negative 18x plus 6y equals 24. Okay, so now let me eliminate. So it looks like this 18x and the negative 18x, that cancels. The negative 6y and the plus 6y, that cancels. Negative 12 plus 24, that actually equals 12. So on this side, everything canceled. I can't just not write anything. So if everything cancels, I have to write 0. Alright, that looks weird too. So one of these I have negative 2 equals negative 2, and the other one I have 0 equals 12. Well, let's figure out what each one is. So if you have negative 2 equals negative 2, these are equal. And I might ask you, when are these equal? Well, negative 2 is always equal to negative 2. This is an identity. If you have a number on one side and the same number on the other side, they're always going to be equal. Alright, and if you go back to the 3 options, we have one solution, no solutions, and infinitely many solutions. This is going to be infinitely many solutions because they are always equal. So I'm going to write infinitely many solutions. Alright, so no matter, these lines are going to be the same exact line, and any solution counts. Alright, this one over here. These two things are different. You might be thinking, okay, that's probably no solution. And you would be right. This is no solution. Why? Well, if I ask you, when is 0 equal to 12? 0 is never equal to 12. So there will never be a solution to this system, right? There is nothing that will make these two lines equal to each other. They never intersect. So if you have two numbers that are not equal, this is when you write no solution. So this is a nice chart that has all of the possible outcomes when you have a system of equation. All right, if you look over here, how are you solving it? If you're graphing it, you could either have parallel lines, the lines intersect once, or the same exact lines. If they're parallel, you have no solution. If they intersect just once, that's when you have one unique solution. And if they're the same exact line, that's when you have infinitely many solutions. On the other hand, if you solve by substitution or elimination, the outcomes are the same. Right? You could have no solution, infinitely many, or one, but the way it looks is different. So if the variables cancel and the sides are not equal, that means no solution. Each variable that has one solution, like x equals 5, y equals 2, that means one unique solution. And if the variables cancel and both things are equal, like if you have 5 equals 5 or negative 2 equals negative 2, that means you have infinitely many solutions. So that's it. Good luck with this packet. Good luck on the mastery check. I'm going to throw some things at you. You might have to know. I'm not going to tell you it has no solutions. I'm not going to tell you how many it has. You need to tell me. Does it have no solutions, one solution, an infinite amount of solutions? You need to let me know. All right. So that is it. Darkus out.